All right, guys, this is section 4.7. It's called Complete the Square. Okay, what we're doing is we're trying to turn a quadratic into something really nice like that. The reason we want to turn it into something nice like that is because if we factored that, it ends up being x plus 3 squared. If we can turn the quadratic we're dealing with into something like that, then we can solve it by square roots. Okay, so that's what we're shooting for here, is to be able to use square roots to solve. Because square roots works whether we have imaginary answers or not. Factoring doesn't always work. Factoring only works for kind of special quadratics. They have to be certain numbers for it to work to be able to factor it, right? Because when we do that x, if it doesn't, we can't find the numbers, then we called it prime. You couldn't factor it. With completing the square, we can solve any quadratic. So it's a little stronger tool that it works no matter if the problem factors or not. Okay, so what we're trying to do is turn a quadratic into what's called a perfect square trinomial, and then we can use that to use square roots and solve it, is what we're trying to do. Okay, so let's just start with some examples, and we're going to solve by completing the square. All right, so this is a method that I will be asking you to show me how you did it that way when we take a quiz on Friday. Okay. All right, so example A. Very first one will be an easy one. X squared minus 16x plus 8 is equal to 0. Okay. Now, it's equal to 0, so our instincts should be to try to factor that. So if I tried to factor that, I would say, okay, what multiplies to be 8 and adds to be negative 16? Is there anything that does that? 4 times 4 is 16, but 4 plus 4 is not 16. So and it doesn't multiply to be the right number. The only other option would be, well, 4 times 2 is 8, but 4 plus 2 is not 16. So it doesn't work. So what we see here is we have a quadratic that won't factor. So we got to solve it some other way. Now, there are other methods, but we want to focus on completing the square today. So the method you want to use for completing the square is first subtract the constant. Subtract the constant. So I'm going to kind of maybe over here on the side write the steps. Subtract the constant. That means the plain number. Subtract that. And get x squared minus 16x. I'm going to leave some space, and I'm going to have the minus 8 over here. Okay? I'm leaving space there for a reason, because I'm going to use that space to complete the square. All right? The next thing you want to look for is make sure a 1 is in front of x squared. Okay? Is there a 1 in front of this x squared? Yes. If there's another number, we'll see some examples in just a little bit. We would just divide everybody by that number, and then we get rid of it. Okay? So we want to make sure there's a 1 in front of the x squared. It makes doing the complete square a lot easier when it's a 1. Okay? Just like factoring is a lot easier when there's a 1 there. All right? The next thing we want to do, take 1/2 b. What's 1/2? All right, got to go kind of back to quadratics in general. B is always where? It's in front of the x, right? So we're going to take half of whatever's in front of x. So half of negative 16 would be negative 8. So don't lose the sign, because that's important, okay? Now, we're going to square that. This is the part that does the magic, okay? 1/2 of negative 16 is negative 8. Okay? I'm going to add 64 to both sides. Squaring that half of b. I'm writing this over on the side because I need to know what half of b is in just a minute, because this is what makes it really easy to complete the square when I know what that number is. But I've got to know squaring that adds 64 to both sides. Okay? Now, what that does is it makes things work out really nice. On the left-hand side, what you've done is you've created a perfect square trinomial that always factors the same way.
When you take half of it, do you still leave it as negative 16?
Yeah, we're still going to leave it right there. We're going to, this plus 64, maybe I'm going to put that in a different color. Let's put plus 64. So the red part is the part that was already there. The plus 64 is the part we're adding to it. The factoring over here, we're making it happen a certain way. We're making it be a perfect square trinomial. It's always going to be x plus half of b. Well, half of b was what? Negative 8. Okay. Quadratic always factors as 1/2, or excuse me, x plus 1/2 of b squared. Okay. Always. You're making it do that by completing the square. Now, on the right-hand side, are these like terms, negative 8 and 64? Yeah, so put them together. Be 56. All right. Now we have a problem that can be solved by square roots. This looks like what we did yesterday. We can take the square root of each side. And so the last thing you would do would be solve by square roots. Okay. The factoring of this, it's always going to factor as x plus whatever half of b was. B was negative 16. Half of negative 16 is negative 8, so that's x minus 8. It's always going to factor that way. Okay. Now we just need to work this out. So on the left side, we got x minus 8. The right side, we got plus or minus, and then we did break down the 56. 8 and 7, 4 and 2. Pair 2, so that's 2 radical 14. Get x by itself. Eight plus or minus 2 radical 14. And we found the solutions to that original problem by completing the square. So it's got a few steps, but it makes the problem work out where we had no option before as far as we couldn't factor it, it wouldn't factor. So we had to find some way to solve it, and completing the square is a good method to solve it. It works just fine. Yeah. So, but we're going to use quadratic formula would also work, but we need the skill of completing the square to do some stuff next in the next set of things that we're going to do. So we need this skill to help us. This is why we want to learn it here. All right. So let's look at another one similar to that one and see if we can follow our steps. We want to solve this by completing the square. Let's use x squared minus 10x plus 6 is equal to 0. So this is very similar to the first example. We want to try to solve that by completing the square. So the first thing that I want to do is what? Subtract the constant, which would be the 6, right? Or move that, whatever. If it was a minus 6, you'd add it, whatever. Get it away from the things. And then I need to know what's half of b. What's half of negative 10? Negative 5. So how much am I adding to each side? Where's that 25 coming from, Kay? Yeah, it's a good question. Where's that coming from? Kay, you said 25. Where'd it come from?
Negative 5 squared.
That's right. Half of b. Whatever half of b is, you're going to square it and add it to both sides every time. Okay. The right-hand side's just numbers. It's negative 6 plus 25 would be 19. On the left-hand side, we can now factor that trinomial. It's always going to factor as what? And half of b is negative 5. So it'd be x minus 5 squared. Always going to factor that way.
This is where it gives me all the square root crap.
Oh, this is the easy part. Once you get here, it's easy, in my opinion. This part's the hard part to me. I factored this trinomial. If I did the x method to factor that, what multiplies to be 25 and adds to be negative 10? Negative 5 and negative 5. That's x minus 5 and x minus 5. That's the factored form of that. Okay? You can kind of do it without even thinking because you made it factor that way by completing the square. When you did this plus 25 on each side, that makes it factor like that. You're making it happen that way. Always. Always going to be whatever your 1/2 b is. And then we take the square root of each side. Plus or minus on the side with a number. That's x minus 5 is equal to plus or minus. 19's prime, so it doesn't break down any. So then I just need to get x by itself. 5 plus or minus radical 19. Yes, it's 5 plus radical 19. Be some decimal form of an answer. Then 5 minus radical 19. All right. Let's see if we can do another one here. Example C. Let's say we had let's do x squared plus 8x equals 1. So maybe they change it up just a tad.
No, we can't do this.
Yeah, we can. Yeah, you can.
You just messed us up.
Why is it one less step? Right. You don't have to move the constant. It's already over there. So all we need to do is do the complete the square part. So I'm thinking, okay, I just need to space this out a little bit. And how much am I adding to each side? Because half of 8 is 4. We square that. So I'm adding 16 to both sides. 17 on the right. On the left side, so my factor is x plus 4 squared. Why is it a plus this time and not a minus? Because it's positive. Yeah, that's a plus sign there. That's a positive there. So that's a plus there. Right. So when you take the square root, it won't break down. Change colors there. Square root. X plus 4 is plus or minus radical 17. Subtract 4. Negative 4 plus or minus radical 17. Not too bad. It's really not a bad method at all. It just gets a bad rap because it's got several steps to it. But quadratic formula has several steps too. So they're equivalent in my book, but my book's not exactly written like yours is. So let's look at one that maybe it's a little bit more difficult because of the number that they choose. You are psychic, Kegel, because that's what this problem will have. Yeah, you can. Not that bad.
There's not a half or a
Yeah, there is. 3 over 2. All right, so yeah, the half of b. So here, this one's already the one step ahead. It's already got the constant over there. So half of b, half of -3, is -3 over 2. Right. So I'm adding 9 over 4 to both sides. Good job. That's perfect. So I just need to work out what's 7 plus 9 over 4. 28 plus 37 over 4. Yeah. And then on the left side, what's my factored form? Good, Hunter. X minus 3 over 2. It's still that half of b that you found. It's no different, just got a fraction on it. Process is the same. And then square roots. And this one works out real nice because when I do the square root of that 37 over 4, I get the square root of 37 over 2 because the square root of 4 is 2. If we're gonna, anytime you take a square root of a fraction, you're going to split it apart, take the square root of the top, divide it by the square root of the bottom. Worked out real nice here because the square root of the bottom was a 2. Now we just need to get x by itself. Right there. Because that's half of b. It's always going to factor as x plus whatever half of b was. Half of b was -3 over 2. Or 1.5 if you're thinking decimal wise, but I'd rather see the fraction than the decimals. Add the 3 over 2. 3 over 2 plus or minus square root of 37 over 2. That's 2 answers that we're finding there.
So really, if you give us 20 problems, we're finding 40.
Yeah.
40 answers.
Yeah, you should have 40 answers when you do a double number of problems. Okay, so far every one of these has had what in front of x squared? 1. Guess what the next one has?
A number.
A number. Okay, so we got to deal with that.
I was hoping a 1.
What if it's 0?
Then it wouldn't even be there. Yeah. Then it's linear and it's even easier to do. Okay. Example E. Let's kind of ease into this. Let's say we had 3x squared plus 6x equals -15. Go ahead and start you a step ahead. Now, the constant is already moved, so it just got the x stuff on one side. We can't just do square roots straight away because we got the 6x in there, so we need to take care of that, complete the square here. So, but the 3 in front of the x squared is the problem. How do we get rid of a 3 in front of x squared? Divide everybody by 3. This one works out really nice because we end up with, 3 goes into everything. X squared plus 2x equals -5. That works out real nice because now when I take half of b, it's not a fraction. So what am I adding to both sides? Half of 2 would be 1, and 1 squared is 1. So I'm adding 1 to each side. So that's a -4 on the right side. That's good. We know how to deal with that. We talked about this yesterday. And then, no, because I want to factor this. Once I've added 1 to both sides, I want to get the factored form of this, which is x plus 1 squared. And now we can take the square root of each side. plus 1 plus or minus what? 2i, yeah, 2i. Plus or minus 2i. Because we got the square root of a negative, so that's the I, and then square root of 4 is 2. Now we get x by itself. And Jordan, this is where you subtract 1. Negative 1 plus or minus 2i. And there we have a complex solution to that, which definitely would not have factored to begin with. Okay. Not bad, not bad. Easy enough. You know, that's 1, 2, 3, 3 lines of work. That's not. I don't think that's pretty short.
2, 3, 4, 5, 6,
Could be worse.
6 lines.
May. All right, let's look at another one. Kind of similar to that. Let's say we had 2x squared plus 16x plus 8 equals 0. So what do I do first? You could divide by 2 at this step, or you could move the 8. It doesn't matter which one of those you do, which order you do that in, okay? When I look at that, I see everything's divisible by 2. That's what I see first. So divide everybody by 2. I like doing that first. Okay. So we got rid of the 2 that was in front of the x squared. That's a good thing. The next thing we do is what? That's right. Move the 4. That's that constant term. That's going to give us x squared plus 8x is equal to negative 4. Now we need to find what? Half of 8x. Half of 8x is, so I'm going to add 16 to both sides. $12 on the right-hand side. Left-hand side factors as, good job. And now we take the square roots. Two radical 3. You guys have done a lot of simplifying of radicals lately, so hopefully some of them are memorized. You can see square root of 12, you know it's 2 radical 3. You don't even have to do the factor tree for it, hopefully. What's happening. Some of you that'll happen with, some of you may not happen as quickly with, but you can get there. Okay. So there we get our answers by completing a square. Works out really nice when that number goes into it evenly. Let's look at one where it doesn't. So you've seen it. Okay. We're about done. All right, so let's say we've got 3x squared minus 5x minus 8 is equal to 2x minus 3. This one's a little bit, this is our last one, so I want to really ramp up the toughness here.
Do you get like terms together?
Yeah, we do want to get like terms together. That's absolutely the right thing to do. Anytime we're trying to solve equations, that's what you want to do.
Do you add 8?
You could add 8 because you're going to have to move the constants over to the other side anyway, right? So how would I move the 2x again? Subtract it because it's positive. And then, so that's going to be 5 on the right-hand side. The left-hand side is 3x squared minus 7x. And then I'm going to leave some space. I really got one more step to do before I really need that space. But divide everything by 3. Doesn't go evenly this time. It does on the first term. That's the one that's important for it to go evenly into. If it doesn't, yeah, something is, the wires is not connecting right or something. All right. Now, half of B. Notice I've been writing it like this every time. -7/6. 49/36. I just need to know what 5/3 plus 49/36 is. Man, help me out. How much? 109. Y'all get that? Y'all agree? I just want to make sure. I don't want to get the wrong number there. And then what's the factor on the inside? X minus 7/6, or X plus -7/6, whichever one you want to write there. 7's not looking. Okay, now square roots. That's the right step. Works out real nice because the denominator is gonna be a nice square root. Square root of 36 we know is 6. 109. That's kind of a weird number. 108 would have been really nice, but it's not. So I think 109 is prime. And when I say I think, it is. Okay. And then on the left side, we got X minus 7/6. And all we got to do is add 7/6. So X is equal to 7/6 plus or minus radical 109/6. That's as tough as they get in this section as far as solving goes. They don't get any tougher than that, honestly. So completing the square is not that bad. All right, so this is what I want you to work on today. I won't do a ton of them, but on page 288, let's look at 3 through 11, and then 23 through 33, and then I really like the application problems. I want to do those. Why are those different?
Stressed all weekend, I had to listen to enough sense to know how to get to bed. I'm gonna burn our brains up.
We got church. I got church.
I gotta all wake them up. Hey,
All right, guys.